Hi and welcome to my channel. Today I'm going to take a look at the classic TRS-80 Model 4. The Model 4 first appeared in the 1984 Radio Shack catalog, and the retail was $2,000 US for a 64K machine with 2 drives. That's roughly equivalent to about $5,000 today, so this was a pretty expensive machine back then. If you're into Canadian dollars, it's about 7,000 Canadian dollars, so it wasn't cheap at all. The Model 4 was the premium machine that was actually in Radio Shack stores. As a kid, I always looked at these things with a certain amount of desire, seeing them behind the counter. But strangely, the Radio Shack color computer, which is what I grew up having, and was also marketed by Radio Shack as a toy, was in a lot of ways a lot more powerful than the Model 4. Now I could go into the relative benefits of the 6809 that was in the toy machine versus the Z80 for business, but I'll save that for another day. Now most Radio Shacks wouldn't actually have a demo Model 4 just sitting around. $5,000 was, too much inventory to tie up just sitting there for sales. But the Radio Shack daily report system did run on the Model 4, and at the end of the day, the store manager would tally up the sales, and they would enter it into the Model 4, and they would make a phone call, a modem call to head office, 300 baud modem, and it would send all the daily report info to head office, where it will be processed by a tandem mainframe, which one day maybe I'll get into those tandem machines. They're pretty cool, not that I know too much. As a kid, I remember the best BBSs were running on Model 4s. And when I got one of these machines for myself, I expected the amount of software to be amazing, lots of business software, lots of terminal software. As it turns out, the Coco actually has way better terminal software available for it today if you want to use it as a dumb terminal. So a little bit of history. The Model 4 came from a line of machines that started with the Model 1, which was introduced in 1977. And that was actually just known as the TRS-80 when it came out. There were a series of incremental improvements. The Model 2 turned the Model 1 into a business computer. The Model 3 looks very much like this, except with a silver case, and has a little bit of a difference as far as functionality is concerned. But the core architecture remains the same between the Model 1, Model 2, Model 3, and Model 4. It's a Z80 processor, a 6845 video display generator, roughly 64K RAM. If it has more, it's banked in 64K banks. The Model 4 also had an option for a high-res monochrome video card, and this was 640 by 200, I think, was the resolution. It was $250 US, and it gave you this monochrome display so you could do graphics. Hard drive was also an option as a large external unit. That 5 meg hard drive was $2,000 in 1984, so really expensive. So the machine has 2 5¼ inch drives. They're single-sided units, 180K per. It has a standard keyboard with a keypad on the side. Now, there's a lot of characters that are missing from this keyboard. So for example, the braces that you use in C, there's no key for it. So there's a set of key combinations that you have to remember in order to generate those keys. There's a reset button here, and the power switch is actually on this side here, so it's kind of hidden. The brightness and contrast controls are on the side of the unit, and a little hint, if you see one of these things for sale, the owner may think that it's broken, but the reality is these controls aren't adjusted correctly, and it's a little tricky to get them to go. But if you see one of these that has a black screen, nothing appears, try that first. You might get yourself a working Model 4 or Model 3. To boot up the machine, you simply click reset and the drive starts running. Close the drive and your DOS will boot up. So on this machine I'm using LS-DOS, which is the latest disk operating system for the computer. This version hasn't been patched, so it doesn't actually support dates past, I think, like 1995. So I'm going to just punch in 1987 here. And then enter the time, and it will boot to your LS-DOS prompt. One thing to note is that these drives actually have a flaw in them. If you power off the computer with the drive door closed, there's a very good chance you will zap whatever disk you have in the drive. It's a problem with the drive itself. You have to open those up and then turn off the machine. The screen is an 80 by 24 character screen. It is a green screen in this model. Some of the early Model 4s, they actually have a black and white screen. The Model 3s, Model 2s, and all the previous machines, they're all black and white screens. So Model 4 was really the first one where they moved over to a green screen, which is a bit more pleasant to look at. The video display generator in this machine is a 6845. The 6845 is actually a really popular chip. So the CGA cards use them. I believe the EGA cards had them in them, and even your VGA cards have an emulation mode for the 6845. Unlike a lot of video generators, 6845 doesn't constrain you as far as character shape, what your character set is, what your screen resolution is. It just manages the printing out of the pixels on the screen, which is why that same chip is used in so many different display drivers. I'll turn this machine around. We can take a look. Let's see what we got at the back there. So at the back, there's not much, just a cassette port back here. But what's really interesting is on the bottom of this machine, I've got my little crummy little RS-232 cable there. On the bottom, you've got an RS-232 port. You've got an expansion port, which is really connected right to the bus. So this is where you plug your hard drive in. And you've got two expansion card slots for external floppy drives. So you can pop in a couple extra drives in there if you want. Here you can see the power switch, and here are the brightness and contrast controls. TRS-DOS was created by a company called Logical Systems under contract to Tandy. The most modern revisions were released as LS-DOS after Tandy moved away from the Z80 based machines. So this machine right here is running LS-DOS 6.3. The cool thing about the TRS-80 is that the DOS isn't based on CP/M or Unix. So TRS-DOS/LS-DOS has some syntax that'll be a bit unfamiliar for people, if you're used to MS-DOS or CP/M. Interestingly, MS-DOS, while it was mostly based on CP/M, has some keywords that were pulled from, likely pulled from TRS-DOS. So, you can remember Tandy was a major customer for Microsoft at this time. So it makes sense that they would be inspired a bit by the Tandy machines in order to build MS-DOS. Best thing about TRS-DOS or LS-DOS is device independence. It's similar to the way in Unix that you can easily route devices to and from each other. You can also apply filters between devices. So for example, you can route the serial port to a simple terminal program and then apply a VT100 filter to that route. Unlike Unix though, it doesn't quite have the simplicity of everything is a file. There's a distinction between files and devices, but it's pretty good and it's probably superior to MS-DOS, certainly the versions of MS-DOS that were available in 1984. Okay, let's boot up the machine. So first thing, we keep the drive doors open so we don't blow any disks. Then we close it and it will boot up with the LS-DOS screen and enter in a date that is a long time ago, otherwise it won't work. And you can enter in the time. It is roughly 21:35 right now. The machine actually has a real time clock apparently. I don't know how good the timekeeping is in it. It does not have a battery backup, so when you repower the machine you lose your time. The drives in this machine are numbered, so the first drive is drive 0, the second drive is drive 1. You can have many drives in TRS-DOS. I have seen, with hard drive systems, 6 drives. I don't know what the limit is, but it's quite a bit, so it's not very constrained, which is great. And I can do a dir, which is pretty familiar, and that will give me a directory of the disk. So here's my files, the type that they are, the size that they are, the date that they were set to. Unlike a lot of operating systems of the era, it timestamps files, which is a good feature to have. Any file with a command extension is a program. Any file with an FLT is a filter, which is a special type of program. To execute a command, you can pick any of the commands that you want, and let's find TED command. That's an editor, and I just type TED and it will load it up. Now let's reboot the system here. Okay, Another thing is if you type dir with both drives closed, it will actually do a directory on both of the drives. So it does the first drive and it does the second drive. Something also interesting to note is that the operating system is on the disk. It is not loaded into RAM unless you specifically order it to. So if I try to do a dir with my OS disk open, my OS drive there, it's looking for the dir command on disk and it can't find it, so it is going to fail at some point here. The basic commands are pretty straightforward if you're familiar with MS-DOS. To copy a file, I just use a copy command. So I'm going to copy com.command over to drive 1. So copy com /command. I said com.command. It's actually slash. TRS-DOS does not understand the dot as the extension separator. 2 1. And that should work. File access denied. Copy. Let's try another file. Copy log.command :0 2 1. No. Looks like we have a bad DOS disk here, which is a bit frustrating. Okay, so let's take this thing apart. I think it's time. Quite heavy. Okay. Okay. Pretty much removed every bolt there, and I've removed all the screws, I think. Oh, there's one still in there. Okay. Now it should come apart. Okay, it's coming apart. So the trick to these is that you can actually break the neck off of the CRT. So you kind of want to take a look in the disk drive bay there while you're opening it up, and then that way you can get in there without breaking the CRT. Now, why is it not coming apart? Still a screw there. Still got a screw here. There we go. Okay, so let's pull this thing apart now. There we go. Be careful. There we go. And the CRT unit you put to the side, because there's a bunch of connectors. There's a ground connector and whatnot there. So here we have it. So from the front you can see the keyboard unit. It is screwed onto the main body of the case. There's the two drives there, and there's a bit of space in between them. There's actually quite a bit, so could probably fit a hard drive or something in there if I really wanted to. And there's something interesting here. This is a power supply. That's a replacement power supply. I pulled one out of a PC to replace the power supply on this machine because the one that was in it was fried. But what's really interesting is that behind this there's actually a second power supply. So this unit here, it has two separate power supplies used for the system, which is quite interesting. There are cables coming up here, power cables going to the motherboard. Motherboard's on the back side here. And then we have our video cables are coming and going to the CRT controller card there. If you pull one of these things apart, it's got a CRT in it. There are high voltages, you know, a couple thousand volts in there. So be very, very careful. And in fact, if you look here, there are two power supplies that aren't insulated at all. So there's actually 120 volts coming into these power supplies right now, just sitting here. If you're servicing the machine, pull the power plug, because you don't want to kill yourself, just tinkering around in here. It's not like a, modern computer where the power supply would be separate. So here's the back of the machine. Here's the motherboard itself. And hiding in between the motherboard and this back plane, there's a card back there. This is actually your RS-232 card. Bit hard to see in there. And then on the other side, I've got my disk controller card. So there's two controllers kind of nestled in there. The motherboard itself is mounted on the back panel of the case. It's not sitting, at the bottom. It's at the rear of the whole case there. And the funny thing about this board is that it's got little correction wires all over the place. I mean, I've never really seen a board that has this many on them. So you can see from these logic chips here, we've got little patch cords going to from one chip to another to address bugs that were in the system, I guess. Here you can see 64K RAM, so we've got one chip for each of the 8 bits in the memory. So on this side we have a bank of empty sockets that can be used to upgrade the board to 128K. Unfortunately, you can't just pop in a bunch of chips and have it work. There's a PAL chip that needs to be upgraded in order for it to recognize the other 64K. After you do that, I don't know of any software that actually used 128K. Maybe it's out there, but I don't know what it is. So, whether that's useful or not, who knows. So we've got a Tandy branded chip here. Something like that. If we look at it, a 24 or 28 pin chip with Tandy on it, that's probably a ROM chip. There's a Hitachi chip of some sort. It also looks a lot like a ROM chip, to be honest with you, but I don't know what the structure is, how many ROMs this computer has. A lot of discrete logic chips on this board. In fact, there's a ton of them. There's probably about 30 or 40 of them doing different basic logic functions. Over here we have the 6845. This is the video display generator chip. 6845 is a pretty simple chip. So it doesn't actually know anything about character generation. It knows really how to drive the screen, drive pixels. It doesn't know how to generate characters or anything like that, which is why that chip is used in CGA boards, EGA boards, etc., with no problem. A lot of these logic support chips are probably supporting functions on that 6845. In newer VDGs like the 6847, you don't have all these chips all over the place in order to drive your monitor. It's just one chip able to basically drive the monitor itself. Mind you, the 6847 has horrible graphics and horrible character generation capabilities, so this is actually quite a bit superior with its chips and whatnot. So just below the 6845, we've got the Z80 chip. The Z80 chip's a CPU, and it's a chip that if you came from that school, you either loved it or you hated it. I was one of the haters. I was a 6809 guy, but the Z80 is actually quite a good processor, able to run up to 4 megahertz, used in all the TRS-80s, used in a bunch of computers. Very popular chip. The Z80 itself is based on the 8080. As far as I know, it is machine language compatible with the old 8080. However, the assembly language is different. They did that in order to get around copyright issues. But as far as I know, this is actually a binary compatible with an 8080. Here, there's a header. There's a 34-pin header. Now, because it's 34-pin, I'm kind of thinking that might be a disk. I don't know what that is. That can't be disk. No, maybe that's video. That actually could be where you plug in your high-res video card. It'd be interesting if anyone knows their Model 4s to let me know what that header is for. I'm not quite sure. Down at the bottom, we've got a few more what appear to be ROM chips. Now the VDG, because it doesn't have a character set built into it, it's quite likely that these ROM chips are used in order for character generation. At least one of the 5 that I think I've identified on this board it's going to have your character set built into it. Unlike a lot of machines of the era, this one has 4K of RAM specifically dedicated for the video screen. So in a typical small computer this time, you would have in your main RAM, you'd have a block of memory that was directly mapped to your video screen, and you poke some bytes into that memory, it will appear on screen. Well, this system here uses 2 static RAMs, 2K RAMs, to give you a 4K video RAM, which is quite an advanced feature for the time. And that allows you to keep your main RAM as working memory and have specific memory for your screen. And at the bottom we have our expansion slot. This is where you'd plug in an external hard drive. It's kind of interesting. There's actually it looks like pads for jumpers that have been, it's on the board here, but there's no jumper cable. So it might have been an option on one board or at some point in the future to have pin headers on here and to use a pin header cable as opposed to using one of these card edge connectors. We've got some fancy blue chips. Can't really see what the number is on that. That's pretty cool. We've got some discrete logic here. Here another nice blue chip. 74LS LSC8N. LS8 probably. And we've got another classic. Look at that guy. Well, that's really nice, eh? A little logic chip there. Great. On this side we've got a relay, and with all these diodes and everything, I don't know what section of the board this is, but it looks like it's this is our power section here. Yeah, it must be, because we've got our power input at the top here, and we've got all this circuitry here, a bunch of diodes, and then we have a relay that clicks when you turn the system on. And then we have over here a 12.6 megahertz crystal and a 20 megahertz crystal on this side. So I'm going to guess this one's your video display crystal and this is your clock crystal. I think it was a 4 megahertz machine, so divide it by 5, it'd probably be that one, but at this point I'm guessing, don't really know. Got lots of discrete, capacitors and resistors and whatnot here. There's a jumper over here, and that one goes to the sound amplifier. So it's not a sound card by any means, but I don't know if I can get this shot here. Yeah, so here's the cord, and then it goes into a speaker, a little beeper right in there. And you can see there's a little amplifier there as well. The Model 3 did not have sound built into it. So if you wanted to get sound, what you'd actually have to do is plug into the cassette port, and you'd plug a little amplifier into there. Radio Shack used to sell these small 9-volt battery powered amplifiers, and you could use that to get sound. So if you wanted to play, Ghost Hunter or whatever, you'd have to plug in the cable there to get your sound. This here's the jumper for the disk drive controller. It looks like it should come out. It's one of those Mylar connectors. I've tried pulling on it, and it will not come out by any means. And I'm kind of worried that actually I've damaged it by doing so. So my advice to you is don't try to pull that out. So that Mylar connector goes to the drive controller, which is down there. And you can see a standard floppy disk connector right there, and the controller there. Now the controller itself is actually very similar to a Radio Shack color computer controller. Uses the same controller chip, but the ROM is different for the drive controller. And actually I don't know if there's a ROM on there, or if the ROM for the drive is part of the motherboard. An interesting thing about this machine is all the shielding everywhere. Now, if you know your TRS-80 history, you'll know the TRS-80 Model 1 was actually pulled off the market because the FCC complained to Tandy about the amount of RFI it was spitting out. So it actually had to be replaced, and that was the reason the Model 3 came out. With the Model 4 and Model 3, they put shielding everywhere to protect from that problem. I'm just going to pull this drive really quickly, let you take a look at it, and look at those discrete components on that thing. It's very much 70s tech. Power supply's gone. And there we have it. A full height floppy disk drive. Big motor on that thing. And you can kind of get a view inside of there of the head mechanism. I mean, everything here is really overbuilt. It's a big block of aluminum. Underneath you can see the head motor. This is a stepper motor to move the head back and forth, and a belt drive which goes to the actual spindle motor. And if you look at those symbols on the bottom there, that's for setting the speed of the spindle motor. You'd use a strobe light and point it at that, and if you got a steady picture, that would mean your speed was correct. And you'll see that on the bottom there, there's a 50 hertz and a 60 hertz setting. So that's basically it. Model 4 itself is pretty simple. Most of it's disk drives. Lots of empty space here. And that's basically about it. Thank you for watching my video. I hope you enjoyed it, and I hope you'll come back to my channel soon.